All right, this is problem number 26. Again, Bayes' theorem, nothing different than anything going on in the last several problems. So here's our given data. We have some model years of cars, we have portions of the totals, and we have probability of getting into an accident. So let's create a sample space, starting with a visual representation, and then moving on to creating the fraction. We let this box represent the universe of our problem, and we'll go from bottom to top. 46% of the total is in this other category. 20% is in the 2012 category. 18% is in the 2013 category. And maybe that'll do there. And then the remaining 16% is the 2014 category. And then we're going to come back horizontally and do the probability of accident. So we'll exaggerate the size just so our numbers don't get too cramped together. 4% chance of accident for the other category. 3% chance of accident for the 2012 category. 2% for the 2013 category. And then 5% for the 2014 category. So not to scale, but it doesn't have to be. So now let's have a look at the conditional statement that we're given. An automobile from one of the model years 2014, 13, and 12 was involved in an accident. So the first part of that statement, the years 2013, 2012, 2013, 2014, we're limiting ourselves to these columns here, these three categories, and then was involved in an accident, so that's above the line here. So we're just going to shade in the area. That is our limited sample space based on the conditional statement. And then we're asked to find the probability that the model year was 2014. So what is the ratio of this area to the total area from these three boxes? Let's write out the fraction. We'll have 0.16 times 0.05 as our numerator. We'll have that part will repeat again here. And then let's go to the next one, 0.03 times 0.2 to take care of 2012. 0.03 times 0.20. And then last but not least, 0.02 times 0.18 to handle 2013. So if you run all of that through the calculator, you're going to get the repeating fraction .45, 45, 45, and on and on and on. So answer choice D is .45, so that's going to be the correct answer here. So remember, when you're doing Bayes, you limit the sample space based on the conditional statement, and then for the numerator, you use the value that you're specifically asked for.